Section 5.3.5 practice, modeling with systems of equations, which is essentially just word problems. So number one, find the value of two numbers if their sum is 12 and their difference is 14. Well, we have two numbers. I'm just going to say those numbers are x and y. Those are my two numbers, x and y. Now the sum is 12, so it means we add them up. X plus y equals 12. And the difference is 4. Oops. And their difference is 4. So we have x minus y equals 4. So I need to solve this system of equations. I'm going to do it by doing substitution. Now I see down here we have, it's easy to get x by itself. So if I add y to both sides, I get x equals 4 plus y. So now I'm going to take this 4 plus y for x, insert it in to this x up here. So I'm going to have 4 plus y equals 12. So 4 plus 2y equals 12. 2y equals 8. So then y equals 4. Y equals 4 there. And if y equals 4, to figure out x, plug it back in. So x equals 4 plus 4 for y. So x equals 8. So those two numbers are 8 and 4. And pause the video and try number 2 on your own. Number 3, flying to Kampala with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers an hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in the still air. So for this, you have to think about how the speed the airplane says it's going, the speed that the engine says it's going, can be affected by the wind. So say, for example, the plane's going 500 miles an hour. Well, if they're going right into a very hard wind, the plane really isn't going 500 miles an hour. The wind is slowing it down a little bit. The wind slows down the plane, even though the plane says it's going at a certain speed. So now it's up to us to figure out how fast the plane really was going when you take into account the wind. So flying to Kampala with a tailwind, a plane averaged 158 kilometers per hour. So there's our first sentence right there. Now I'm going to let S be the speed at which the plane says it's going. And when I say the plane, I mean like the odometer. I'm going to let W be the wind. Now, if it's flying with the wind, that means the wind is adding to its speed. So we can have S plus W equals 158. Now, on the return trip, it only averaged 112 kilometers while flying back into the same wind. So now the wind is taking away from the plane's speed. So that'll be S minus W equals 112. So there's my two systems of my two equations. Let's make the system of equation. Now, once again, I'm just going to use substitution to solve on the bottom there. So I have S minus W equals 112. So that means S equals 112 plus W. So now I can take that S, plug it in for the S up here. So that means I'll have 112 plus W equals 158. So then 112 plus 2W equals 158. If I subtract 112, I get 2W equals 46. So then W equals 23. So this wind of the speed of the wind is 23 kilometers an hour. And that's on the speed of the plane. We can figure that out by plugging it back into this S equals 112 plus W equation. So the speed equals 112 plus 23. So the plane is going about 135 kilometers an hour. All right, let's look at 3. The school that Stefan goes to is selling tickets to a choir performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So we're going to have to make two equations here. Now the first day, so I'm going to highlight the first day, the ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for $38. Well, I'm going to let S be senior citizen ticket and C be child ticket. So on the first day we had 3 senior citizen tickets and 1 child ticket, and they made $38. On the second day, they made $52 by selling 3 senior citizen tickets and 2 child tickets. So that would be 3S again, S for senior citizens, and 2C now, and that equals 52. Now I see we have a 3S in both of those equations. So if I just make one of those S's negative, then I can use elimination. So I'm just make the top equation negative and multiply each of those by -1. So now I have negative 3S minus C equals negative 38. The bottom equation stays the same. So 3S plus 2C equals 52. I add those up. The S's cancel out. Negative C plus 1C just equals C. And negative 38 plus 52 equals 14. So it means the price of 1 child ticket is $14. Now to figure out the senior citizen ticket, remember, plug it into either equation. Let's just plug into this equation. And actually, you can cross out this problem down here because we're not going to do that one. You can cross out that one. I'm just going to continue working into the next question. So 3S plus 2 times 14, because I'm putting in 14 for C, equals 52. So 3S plus 28 equals 52. I'm going to subtract 28 from both sides. So I'll have 3S equals 24. And then when I divide both sides by 3, I have S equals 8. So each senior citizen ticket costs $8, while a child's ticket costs $14. Now 6 is another problem we're not going to do, so you can cross out 6. And on the back page, please do 7, 8, 9, and 10. You do not have to do 11. Please do 7, 8, 9, and 10.